Chapter 2, Section 3, this is the last lesson before your quiz. You guys have a quiz on Friday. Yes, it is a half day. It is going to be 10 questions only. So each question is worth 10 points. So please make sure you guys are studying. Things that you need to study. The first lesson we covered conditional statements. So you have your conditional statements, your converse, inverse, contrapositive, biconditional. Then we did inductive, deductive reasoning, law of syllogism, law of detachment, and today we're doing postulates. So a lot of vocabulary, please understand what they are, a lot of things to memorize. And with the postulates, I believe there are 7 postulates. All right, so 7 postulates for you guys to remember. But hopefully definition and words, they kind of go together. So definitely pay attention to that. All right, the first 4 we're going to go over, and I'm going to kind of draw them. But pay attention to how I'm drawing. I'm going to kind of go in color order. What goes first? If this image is drawn, then this is the outcome. So looking at the first postulate, this is called 2-point postulates. A 2-point postulate. Through any 2 points, there is exactly one line. Okay, again, through any 2 points. So we're specifically talking about, okay, I have 2 points first. With those 2 points, there is exactly one line. So I'm going to draw it out. So here are my 2 points. Here's 1 point. Here's my second point. We'll name it A and B. With those 2 points, I have exactly one line that goes through them. Okay, 2-point postulate. With those 2 points, I have exactly one line that goes through them. All right, next. I have line point postulate. First word is line, and then I'm going to my points. So it says a line containing at least 2 points. At least 2 points. So a line, if I have a line, so I'm going to do my blue section first. Here is my line. Oh, let me kind of get a brighter blue so you can see it. Here is my line. With that line, I will have at least 2 points. So if you're looking at the first one, I went from 2 points. I did 2-point postulate, so 2 points. Here are my 2 points. Then to my line. But with the second one, line point postulate, I'm going from a line to 2 points. So they're very similar. But again, look at how the word is written. I have 2 points, then line point. Looking at the next postulate, I have line intersection postulate. Okay, exactly what it says. I have 2 lines. So if 2 lines intersect, then their intersection is exactly 1 point. So again, I'm drawing my 2 lines. Should be blue first. I'm drawing my 2 lines. Here are my 2 lines. If I have 2 lines, then I'm going to have exactly 1 point where they intersect. Okay, 1 point where they intersect. Looking at the next one, I have 3-point postulate. We kind of hopefully should know what we're using 3 points for. What do I use 3 points when I'm naming? What do I name? Go to plane, okay? Through any 3 non-collinear points, there is exactly 1 plane.
Can you please send Owen Boyd down? He's leaving.
Okay. All right, drawing this, what does this look like? I have 3 non-collinear points. So 3 non-collinear points. Here's A, here's B, here's C. I have 3 non-collinear points. I'll zoom in for you. Okay, they're non-collinear. They are not on a line. What this is saying is 3 non-collinear points. There is exactly one plane. All of these points are on a plane. Yes.
Could three collinear points make a plane?
Yes, you could have 3 collinear lines. Collinear points, you mean?
Yeah.
Yes, I could have multiple lines on a plane. But for this one, it's specifically telling me that I have 3 non-collinear points.
So 3 collinear points wouldn't necessarily make a plane?
Yes, I could. All right, questions on these 4 postulates? Yes, they are a lot, but vocabulary-wise, they should be pretty easy. You just have to know if this, then what's going to happen? What's my outcome? All right, looking at the next 3. I have plane point postulate. Plane point postulate. So with plane point postulate, a plane contains at least 3 non-collinear points. Okay, so looking at it, what does that mean? Now this one's talking about, last one we said 3 non-collinear points, they're on a plane. Now this one's stating I have a plane, and with that plane, I have at least 3 non-collinear points. Okay, so it's like the opposite. And the other one was 3-point postulate. This one is plane point postulate. So I'm going from a plane to my points. Now I have plane line postulate. If 2 points are in a plane, then that line that contains them is also in that plane. This one may sound confusing, but once I draw it, hopefully it clarifies that. So it's saying if 2 points are in a plane, here is my plane. I have point A and point B. 2 points are in a plane. Then the line that contains those 2 points is on that plane. So I'm going to draw a line through my points, and it's just saying that line is also going to be on the same plane. Okay, so this line is also on the plane with my 2 points. Yes.
Would a line intersecting a plane count as being on the plane?
Say one more time.
Will a line intersecting through a plane, like this, like going through a plane, would you count it as being on a plane?
No. It's just going through, it's not on the plane. The point is on the plane, but not the line. All right, and then looking at the last one, plane intersection postulate. So we did line intersection postulate. Now we're specifically talking about a plane. It says if 2 planes intersect, then their intersection is a line. So I'm going to draw that as best as I can. I have 2 planes. There are my 2 planes, and it's saying those 2 planes intersect. And they intersect, and where they're intersecting is a line. So where my two papers are intersecting is my line. Not a point, it is a line. Questions on these three? All right, looking at the next, we have perpendicular figures. A line is perpendicular to a plane if and only if, this is a biconditional statement, if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects at that point. To every line in that plane. And let me explain what this means. Think of it as if you were to stick, well, first of all, what does perpendicular mean? Does anybody know? Yeah. No? Yes. Good. Two lines that intersect to make a right angle, a 90-degree angle. And looking at this diagram, what shows me that it's a 90-degree angle? Hernan? Those little squares, these little red squares right here, that's showing me that it's perpendicular. So perpendicular figures, this diagram, what this means is a line is perpendicular to a plane if and only if the line intersects the plane in a point. What it's saying is if I give you a sheet of paper and I stick a pencil through it at a 90-degree angle, so straight up and down, if I were to make a line that goes through that point, that line will be perpendicular to my pencil. Okay? It's just saying anytime you make a line through a line in a plane, it's going to at a perpendicular angle, it's going to continue to be perpendicular. Okay, so again, just make sure you know perpendicular means right angle, and it makes a 90-degree angle, and it has to show you that it's a right angle. If it's not a right angle, then they're not going to show you that. All right, looking at example number 1, what I'm going to do is I'm going to leave this image up here. Go back and look at the postulates. Go back and look at the postulates and state the postulate illustrated by the diagram. Go ahead and look for these postulates. So yeah, something like this diagram will be on the quiz or test. That's why I drew the diagrams for you. So you can see what happens first. So if this image, then this will be the outcome. So yes, definitely understand what the image means and how to find the using the image and the definition. Yeah. All right, looking at this diagram, let's go ahead and state the first one. Can someone tell me what postulate that one is? Yes, Delaney. Good, this is line intersection postulate. Okay, line intersection postulate. I'm just going to go ahead and write the definition so you can see the difference between the two because they look similar. So this one is if two lines intersect, then their intersection is exactly 1 point. Okay, that is line intersection postulate. Looking at B, what is this postulate? Yes, Christian? Good, this one is now plane intersection postulate. So they look very similar, they sound very similar. Now again, pay attention to the definition. If two planes intersect, then their intersections is a line. So looking at the first one, I had two lines and they intersect at a point. But now looking at B, I have two planes where their intersection is a line. So don't get those two mixed up, please. All right, next. Looking at example number 2, it says use a diagram to write examples of plane point postulate and the plane line postulate. So we have to know the definitions in order to write these. Writing examples. So I have plane point postulate. And can somebody tell us the definition of plane point postulate? Go ahead.
A plane that contains at least 3 non-collinear points.
Good, so we're going to look at the diagram. A plane that contains at least 3 non-collinear points. Can someone tell me what plane that is and what points are those? Mateus? Okay, so I have points A, B, C. What is the name of that plane? Good, it is plane P. So how I'm writing this example is plane P. So it's similar to the definition. Plane P contains at least 3 non-collinear points, which are A, B, and C. Okay, that's plane point postulate. Now doing the next one, I have plane line postulate. Can someone go ahead and read me the definition of plane line postulate? Logan?
Plane line postulate. If two points are on a plane, and the plane must contain them, is also in a plane.
Good. So if 2 points are on a plane, then the line that contains those 2 points is also on the plane. So looking at this diagram, which 2 points are on a plane that have a line? Okay, points A and B. What's the name of the line?
N.
Line N, and which plane is it on?
P.
Good. So I'm going to use that information and I'm going to write an example according to the diagram. So we said if we had 2 points, so I'm going to start it out. Points A and B lie in plane P. Okay? Excuse me. So we know that information. So line N containing both points A and P okay, so line N containing points A and B also lies on plane P. Okay, so understand what it's saying. First, it's saying I have my points that lie on plane P. So that means the line that goes through those 2 points is also on plane P. Okay, any questions on those two postulates? Plane point and plane line. All right. Example number 3. Which of the following statements cannot be assumed from the diagram? So, looking at the diagram and looking at the statements they're giving us, which ones can we not assume? Meaning, which ones can we not say, oh, I think it might be that? Okay, we can't assume it has to be given to us. So options we have: A, B, and F are collinear. E, B, and D are collinear. Line AB, this little upside down T here, make sure you know what that symbol means. That means it's perpendicular. Okay, it means it intersects at a 90-degree angle. So line AB is perpendicular to plane S. Line CD is perpendicular to plane T. Line AF intersects line BC at point B. So look at these for a second, and who could tell me which one can we not assume? Logan? Good. So looking at it, I have, well, first let's look at ABF. Is ABF collinear? Yes. Is EBD collinear? No. So I'm going to go ahead and write no. How can I tell that it's not collinear? Good. No line is drawn. No line is drawn connecting the points. Okay, there is no line drawn to connect the points. I cannot say it's collinear. I cannot assume that it's collinear. There's no line there. Who can give me another one? Is there another one? Is there another one? Looking at our options. Bryce?
Line CD is perpendicular.
Good. So how do we know it's not perpendicular? Good, there's no right angle symbol. No right angle. Symbol is drawn. So let's look at the one before it. Line AB. Looking at it, line AB is perpendicular to plane T. Or plane S. Yes, it's perpendicular to plane S. They're giving me that little red box. CD is not perpendicular to plane T. There is no red box. And then looking at the last one, AF. Is line AF intersect BC at point B? Yes, it does. Okay, so that we know. All right, and the last one, name a pair of supplementary angles and a pair of vertical angles in the diagram. Who can tell me, what does supplementary mean? Sophia? Yeah. Good. Supplementary is 180. A lot of people got vertical wrong. What does it mean when something's vertical? Vertical angles. If I have vertical angles, how can I remember that they're vertical? Christian? They form an X. They form an X. I see an X here, but I still wouldn't be able to tell what vertical angles are. So who could give me, like, how can you guys tell if it's a vertical angle? Katya? Not necessarily the congruency symbol. Bryce? Okay, they intersect creating equal angles. Yeah, they are. Vertical angles are going to be congruent angles, yes. But that's still not really telling me what vertical angles are. Yeah. They form a pair of opposite rays. Okay. So it has to do with something opposite. So vertical angles, if you think about it, they're like opposite angles. So those two are going to be vertical angles. So they're like opposite. They're like opposite angles. Okay. I like to kind of think of them as, if you think of like your V's, your verticals, they're kind of touching at the vertex. Okay, that's a way to think about it. But we cannot get vertical and adjacent mixed up. What does it mean to be adjacent?
Next to each other.
Right next to each other. They share a side. Okay, I think a lot of people got those mixed up on the quiz or on the test. So please know next time adjacent means it's next to, directly next to. All right, so go ahead and give me a pair of supplementary angles. And please make sure you are writing your angles using your angle sign. And then I need a pair of vertical angles. You don't have to name all of them. Just name a pair. Go ahead and do that, please. All right, supplementary angles, I'm going to give you all of them. I'm not going to write them backwards. So if you wrote it backwards to what I'm writing, just know that it will be correct. So let's go ahead and answer those. So supplementary angles, keep in mind there are two angles that add to equal 180, so they add to equal a straight line. So the first pair you could have had is PWT and angle PWV. You could also have PWV and angle VWQ. You could have VWQ and angle QWT, or you could have also had angle QWT and angle TWP. Again, you could have flipped these. Keep in mind those W's are my vertex, my vertices. It's my vertex. And all of your vertices, your vertex has to be in the middle. Your vertex must be in the middle. So looking at my vertical angles I could have had was angle TWP and angle QWV, or your second option could have been angle VWP or angle TWQ. Those are your options. Any questions on those or unsure if their answer is correct? Yes. P for the vertical? Yeah. So PWV, yeah, you just flip these. The P and the V, that's fine. And Q and T, that's fine. All right, you guys have a review, an extra practice review on Canvas for your quiz, 2.1 through 2.3. That is a very good review to work on. There is also a quiz review with the solutions, but the review that I posted, the 2.1, 2.3 review, has the answers at the bottom, so you could also go over that. Any questions? Yes.
Can we do that tomorrow in class?
We will go ahead and go over that, some of the questions, yes, tomorrow. Any more questions? Yes. The homework is due tomorrow morning. The review is, you're not required to turn it in, but it is in your best interest to study and complete the review for your quiz on Friday. Katia? No.